Hello students, in this chapter we will be discussing about sound. But before starting the chapter sound, we will have to understand few things or the terms related to waves. We know about the structure or the shape of wave. This is the shape how wave is created. This is actually the structure of the or the shape of the wave. Now sound is a form of energy which travels in the form of wave. That is why we need to understand wave. Now, for wave, we need to understand few things. For a wave to be created, we need two things. Okay? Two properties of material. We need two properties in any material to create wave. And these two properties are, the first property is elasticity. The first property will be elasticity. Elasticity means when any deforming force is acted on any body. For example, let us consider rubber band. When we stretch the rubber band and when we release the force, what happens? The rubber band comes to its original position, and this property of any material is known as elasticity. Along with this property, we need one more thing in the material, that is inertia. Inertia means it should have some mass on it. Okay? Then if these two properties are there in any material, then we will consider that the material can produce wave. How wave? Let us consider we have a string. We have a string. If we disturb, wave is a disturbance created in any medium. If we disturb here in this string, let us consider these are the molecules. These are the molecules and so on. If we pull this molecule, if we disturb this molecule, this molecule will come down, and due to the intermolecular force of attraction, this molecule which is coming down will pull the second molecule which is in contact with it. And when this molecule has come over here, due to the elastic property, it will move back to its original position. It will try to move back to its original position. And at that time, when it will move to its original position, this molecule, which was initially being pulled by this molecule, will come down from its mean position. This is the mean position, and it will come down. When this molecule has come down, this molecule will pull this molecule which is in contact with the second molecule. It is going to pull the third molecule. And when this molecule was moving up, due to the inertia, because this molecule is definitely having some mass, and due to inertia, it will overshoot the mean position and move to the topmost position. And here what is happening, at the point when this molecule moves to the topmost part, this molecule, due to the intermolecular force of attraction, will again come back to its mean position. And by the time this molecule has come to its mean position, the second molecule has come to its mean position, the second molecule initially has pulled the third molecule downwards, and therefore the third molecules came over here. When the third molecule came down, it was pulling due to the intermolecular force of attraction, it was pulling the fourth molecule downwards. And similarly, what is happening, we were seeing a structure. This will pull the fifth molecule, will pull the sixth molecule, and similarly, this molecule has initially come here in the first position, then went back to the mean position, and due to inertia, it will shoot up over the mean position, that it will come over here. And when we form the shape of the movement of the molecules, we see a structure has been created. Okay? And this structure is considered to be as the wave. We consider this structure to be wave. And what is happening over here is the molecules, each and every molecule is moving to and fro in its own mean position. It is initially coming down and then again moving back to its mean position, and due to inertia it is moving up. Due to elasticity it is again coming down, and due to inertia it is again going down. And this same thing is happening in each of the molecules. The molecules are not traveling from here to here to here to here or here. The only thing what is happening is the molecule is traveling alternatively. It is moving up, mean position, down, mean position, up. And similarly, all the molecules are doing this. And the disturbance which we have created in the first molecule will slowly reach to its final position up to the last part of the string, and this is how the wave has been created. Here we see a type of wave has been created in which the particle is oscillating. This is the mean position and this is the wave, and what we see over here is this in wave the disturbance is moving in this direction. The direction in which the disturbance is moving is known as the direction of wave propagation. Direction of wave propagation. This is direction of wave propagation, and we see over here is the molecule used to move up, come back to its mean position, then move down and again move back to its mean position. The direction and the oscillation, this is the oscillation of the molecule. This is the oscillation happening over here due to its from its mean position, and this oscillation is perpendicular to the direction of the wave propagation. So this type of wave in which the direction of oscillation of the particle is perpendicular to the direction of the wave propagation, this type of wave is known as transverse wave. We call it as transverse wave. This we have studied, students, about transverse wave. In what happens in transverse wave, the oscillation of the particle is perpendicular to the direction of propagation of the wave. And there is one more type of wave. This is the first type of wave on the basis of oscillation of the particle. And the second type that we study is, let us consider we have these molecules. Okay? Let us consider these are the air molecules. What happens when the force has been applied in the first molecule, it will go and strike the second molecule, and due to the elastic property or any kind of thing, it will move back. The first molecule will move back and the second molecule will strike the third molecule, and then again the second molecule will move back and the third molecule will strike the fourth molecule. Similarly, what happens, this kind of force is happening. Like, let us consider this is the first molecule, this is the second molecule. It will strike the first molecule and then come back, then this moves front, and then again this kind of thing happens, and the disturbance is moving further. The direction in which the energy is being transferred is known as the direction of wave propagation, that we have studied in the previous part as well, wave propagation. And here the disturbance, the molecules are oscillating to and fro. Those molecules are oscillating to and fro in its mean position only. Therefore, in this part, we see that the oscillation of the particle is along the mean direction, mean path, and also the propagation of wave is along the mean path. So here, if the oscillation and direction of propagation of the wave are along the same path, then we consider these type of wave to be as the longitudinal waves. Longitudinal waves. Here in this chapter we are studying sound, and sound is a type of longitudinal wave. It travels in the form of longitudinal wave. And transverse wave we have already seen when you create disturbance in any string. For example, in guitar the strings are created, strings are attached. If you disturb any point, the wave will be traveling over there. So waves created in string is example of transverse wave. Waves created in string. Also, we will, you will see that, for example, when you throw any stone in the pond, you see the wave creation over there. When we throw it, the waves are created over there in the pond, and this kind of, structure has been made. And this structure is known as the transverse wave. The waves created in water surface is also a kind of transverse wave. Okay? It is also a kind of transverse wave. So this is all for the type of waves on the basis of oscillation of the particles along the direction of the wave. This is along the direction of the wave and this is perpendicular to the direction of the wave. If the oscillation of the particle is perpendicular to the direction of the wave, we consider it to be a transverse wave, and if the direction of the oscillation of the particle is along the direction of the wave, then we consider it to be as longitudinal wave.